Hi, my name is Tempest van Schaik, and I am a senior machine learning engineer at Microsoft in a team called Commercial Software Engineering. And I'm very pleased to be speaking at ODSC West. Today, I'll be talking to you about responsible AI in health, from principles to practice. All right, so for today on the agenda, I'll be speaking about the historical journey of responsible AI as I see it, some lessons from biomedical research for AI, and some responsible AI review questions that I find helpful to ask when we're faced with a new AI project. And lastly, some responsible AI tools that I find helpful, that you might find helpful too. But let's start with the historical journey of responsible AI. So when new technology is introduced into the world, often safety and responsibility considerations follow closely behind it. For example, the invention of cars. So the first car was developed and put out onto the road, and then we had the first car fatality in around 1899. And a couple of years later, cars were fitted with windshields and headlights, and roads were also given some safety features like traffic lights, and then the cars had indicator lights, and then seat belts. And believe it or not, the first driver's test only came in 1955. So when we drive cars today, we consider these things obvious and we take them for granted, these kinds of safety features and regulations. But of course, they weren't always there. And I feel like with AI, we're probably at the very beginning of the journey, somewhere around the first windshields and headlights being installed. And through my career as a machine learning engineer, I have noticed a shift in focus from the question of can we do it to should we do it. If you think back to a few years ago, there was a lot of excitement about facial recognition. And this is something that engineers have been researching for decades, trying to identify the human face by measuring different features on the face. And then using AI, we were able to do this. So there was lots of excitement. This is a big engineering breakthrough. And I remember everyone was doing demos of facial recognition, and just generally a lot of excitement and fun. Fast forward a couple of years, and we saw how facial recognition technology can be misused. It can be extremely unfair, and a lot of companies pulled back from facial recognition and are not using it anymore. And so the question has really shifted from can we do it to should we do it? So yes, AI is really powerful, but should we be building these systems at all? So now I'll talk a little bit about my personal journey with responsible AI. And my journey starts with biomedical research because that's my background. I'm a biomedical engineer. So some of the concerns with AI today are familiar from anyone coming from a biomedical research background. There was a really important piece of guidance that came out called the Belmont Report in 1979, which is a set of guidelines for medical research ethics. Now, this report came out after some really unfortunate medical research mistakes and really unfortunate experiments that had happened with human subjects. And this came out to offer guidelines for ethical research going forward. So as you can see, a similar biomedical research has had a similar conversation to what we're having now, but is a couple of decades ahead in establishing responsible ethical principles. So some of the standards from biomedical research that are now considered part of responsible AI are, one of them is dataset transparency. So when you publish a paper in biomedical research involving human subjects, you have to be really transparent about who is in the study, how many people, how many men and women, what different races, what cities do they live in, level of education, and you have to be really clear about this in your paper. And similarly, with AI, we're starting to require that people are a lot more transparent about who makes up the data set or what makes up the data set. So, who was this data set trained on? What kind of demographics? So I think that's an interesting parallel. The next point is informed consent. So just as people need to be informed and consenting to participate in biomedical research, in AI, we're starting to consider that have people actually consented to being part of your training data? And is it ethical to scrape information about people and use it to train a model? To have people consented to being part of your model? The next topic is this concept of group harm versus individual harm, and which comes from biomedical research. So with responsible AI too, we're considering that if the system is incorrect or unfair, that can impact individuals, of course, but it can also cause harm to a broader group. It can also cause a reputational damage or harm to or stigma to the group that person belongs to. So you have to think about these two different types of harm when considering your AI system. And then lastly, privacy. Of course, it's very important that if we're collecting biomedical data for a certain use case, that it remains private and doesn't get shared or leaked for other reasons. And similarly with responsible AI, privacy of the people involved or the systems involved is extremely important. And we've seen how it's possible to leak information about people. So even if we look at someone's browsing history and we look at recommenders, we can be leaking information about that person just based on what products are being recommended to them. So my personal journey with responsible AI starts with my background in biomedical research, which it primed me, and kind of that's my lens for looking at AI. So not too long ago, I had some ethical concerns with an AI project. And I was very fortunate to be supported by my leadership team to ask those should we do it questions. So instead of just diving in and doing it, let's ask if we should be doing this. And the support and tools, the support that I got from my team and the tools that I ended up using prepared me for recognizing and addressing responsible AI issues on lots of future projects. And so I'm going to share some of the learnings from my journey. So now I'll talk about responsible AI reviews. So some of the considerations that we give when reviewing new projects. So my team works on really diverse customer projects. We work with lots of different customers in different industries like healthcare or manufacturing or advertising. And each project is really different from the last. And these are really complex. We work with lots of different types of data. So sometimes it could be text and NLP, could be images, could be structured data, could be audio. So each project needs its own special dedicated considerations about the responsible AI impact. So we created a review board where we can sound ideas and explore and have this discussion. And then we provide responsible AI recommendations to the AI team that will be working on a project. So some of the questions that I find helpful to ask when thinking about a project in terms of responsible AI is firstly, remember that AI is not magic. So ask yourself, is this problem actually solvable with AI? or with technology at all? Or is this more of a social problem that could be solved with a social intervention? And then if it is a technological problem, can it be solved in a simpler way? So for example, sometimes a SQL query to bring back an answer from your data is actually sufficient. And then we don't need to use machine learning, because if we do, it's a lot of responsibility, it requires maintenance, and so just check if you really need to use machine learning in the first place. Next, it's helpful to ask, who are the stakeholders on this project? So who does this project, the system, affect? Think about everyone that it impacts, and especially think if there are any vulnerable groups. So the stakeholders that a system impacts might be, it might be another company and the brand and reputation of that company. It might be government and regulators of some kind. It will be the end users of the system. There could be vulnerable groups like children or the elderly or immigrant populations. So map out everyone who this might affect. And then you can think about the possible benefits and harms to each stakeholder. So try to be really exhaustive in positives and negatives for each of these groups. And that's a really helpful exercise to think through. Next, you can ask yourself, does any of the data used by this model for training and scoring contain personally identifiable information? And if so, you need to be extremely careful with that training data. And often as data scientists, we might have access to more data than we need. So we really don't need people's names and addresses and telephone numbers to train most models. So if you don't need that data, then just don't have access to it, just to be safe. Then you can ask if the model impacts consequential decisions. Like, is this model blocking people from getting jobs or loans or access to healthcare? And if it is impacting consequential decisions, then there might be a requirement for this model to be explainable and interpretable, which we'll talk a little bit more about later. I also find it helpful to think through how the technology could be misused and what could go wrong. So I like to call this Black Mirror brainstorming, where it's named after the UK series, which explores how technology goes horribly wrong. So just think through those scenarios. Then you can ask, does the model treat different users fairly? So are different groups of people treated unfairly by this model? And you might be asking yourself this at the beginning of a project before you have a model, but it's helpful to think through, how would you test if the system was treating different users fairly? How would you measure that? Then you can ask, how does the training data compare to production data? Are they well matched? So for example, if you have a language model trained on Twitter conversations, and then you're using it to find the answer to a medical question in medical literature, the training data and the production data are quite different, or the inference data. And so that data set might not be appropriate, and that can lead to the system not working well. It's also worth asking what the environmental impact of a solution is, particularly for very large models that might take days or weeks to train. Those models can be using a lot of power, and so what is the environmental impact of all that energy being used? And then lastly, if these kinds of questions have raised any concerns, how are you going to address them? You might need to reformulate the problem a little bit, or if you have identified risks, then maybe you can mitigate them. And I'll talk about some of the tools that you could use. I'd like to mention some specific responsible AI considerations for health. So one of them is privacy. This is obviously healthcare data is very, very sensitive, and it's important to keep it to maintain its privacy. So, for example, genetic data. Your genetic data is something that you share a lot of with your siblings and family. So it's not just about your privacy, it's about other people's privacy too when it comes to something as sensitive as genetic data. Next, it's worth being aware that if you are going to work with health data, you often have to, it's obviously very important to handle it securely, and you often have to do training, necessary training to be able to handle that data, real health data. I think an important part of responsible AI with all domains, but especially with healthcare, is that data scientists must work with domain experts. That's really crucial. So as data scientists, we understand algorithms, but we can't be domain experts in every field. So we need to work with nurses and doctors and other healthcare professionals to interpret the results, to make sure that we're not making any incorrect assumptions about the data. And that's really important when you start a project, to make sure that you have those experts that you can talk to. There's also this interesting tension between open and closed science. So on one hand, open science is about sharing data. And if I collected data for one study, if it's beneficial for other studies, it could be helpful to share that. On the other hand, we want to maintain privacy and security and keep people's data very locked down. So I think that's an interesting tension there. It's very important to consider unequal access to healthcare when we're working with health data. And this is really something that varies from country to country, what that looks like, but each country has a history of some kind that's worth considering. Something that I've been really noticed since moving to the USA is the bias introduced to the cost of care. So whenever you have costs involved, you can bring in a lot of socioeconomic bias into your model. So it's really worth understanding that. And then lastly, what's quite interesting is how race and sex can obviously bring in a lot of bias to a model. However, in healthcare, they can be really important disease predictors. Like we saw like we were seeing with COVID-19, race and sex are, very predictive of how you'll fare with the disease for biological reasons and also for socioeconomic reasons. So we can't just ignore race and sex and exclude them from our models if they're very predictive. I wanted to highlight a paper that I found really interesting. And it's about a healthcare model that affected a lot of people in America, where the model excludes race as a feature, yet is still very racially biased because they used cost of healthcare to predict who should get healthcare. Definitely recommend reading it, and I'll link to it. But what I wanted to highlight here is you can't just remove race and sex and other features and then assume that your model is not going to be racially biased. You need to go a step further and really think about what features you're including, and maybe even do some analysis, which I'll speak about. So let me talk a little bit about some tools that I find useful and that you might too. So one of the responsible AI questions I ask is if there is a good representation of all users. So the users of the end system, are they represented well in the training data? And that's where this tool called Data Sheets for Datasets comes from. And I really like this idea because it is inspired by electronics engineering, where when you buy an electrical component, you also get a data sheet that accompanies that component. And the data sheet tells you everything you need to know about this little chip, its operating conditions and how it's connected and so on. And so the authors behind this work are proposing that when you build a data set and share that data set with other ML practitioners, you are very transparent about the data set, who was in the data set, and what are the kind of operating conditions for that data set, what are the limits of how it should and shouldn't be used. So do check out data sheets for data sets. Another responsible AI question that I ask myself is, does the model treat different users fairly? Now there's a tool from Microsoft Research. It's an open source Python package called FairLearn, which I have used. And what FairLearn does is it helps you to explore fairness of a model by looking at, is the model as accurate for different patient groups? So for example, here I have a model with an area under the ROC curve accuracy of 92%, which is pretty good. And then we can break down that accuracy by the different patients in the group. So by female and non-female patients, we can see how accurate was the model for those different groups. And similarly, we can do that for different races in the population. So what I found really interesting about this is that we can't do this fairness analysis or audit unless we are capturing features like race and sex. So instead of shying away from race and sex, if you can collect that data, at least you can measure how fair or unfair your model is, as using a tool like FairLearn. Another tool, this one also from Microsoft Research, also an open source Python package, helps you address the need for explainable or interpretable models. So especially where consequential decisions are concerned, it's important to be able to explain why a prediction was made. And so the Python package is called Interpret ML, and it includes a model called the Explainable Boosting Machine, EBM, which offers high accuracy and high explainability of the global predictions and for specific predictions. So here in this image of this plot, we can see that someone's income can be predicted from capital gains and hours per week. An education number is more likely to give them a high income, and what is likely to give them a low income would be the features in blue, which would be sort of their age and so on. So highly recommend Interpret ML and EBM if you need to have explainable and interpretable models. I wanted to end with some more resources for anyone who's interested. Experts to read and follow. I really like work from Kathy O'Neill, Hannah Wallach, Timna Jibru, Rachel Thomas, Deborah Raji, Kate Crawford, Arvind Narayanan. So check out their work and follow them. A couple of good books, and this documentary called Coded Bias, if you haven't watched it, is a great kind of intro and primer to responsible AI. There's also Kate Crawford's Atlas of AI, and there was recently a redesigning AI issue, and some of these people that I've mentioned appear in these different documentaries and books. I've got a link here to the Obermeyer article about the racial bias. It's fascinating. And also a link to some of the Microsoft responsible AI tools that I mentioned. Another resource is my own team's Responsible AI Playbook. So we share our best practices for engineering, for machine learning, and in particular for responsible AI too. So that's we have a GitHub repo where we share all of our team's best practices. If you're interested in reading about those, follow that link. And then lastly, my team, which is the applied machine learning team, is hiring tons of roles in Asia, in the USA, in Australia, in Israel. So we've got tons of open roles. Check them out at these links. And thank you very much. It was a pleasure to speak at ODSC, and I'm extremely easy to find on Twitter and LinkedIn, and be happy to connect. Thanks a lot.